Okay, in this video we want to solve a Bernoulli differential equation example. So we have y prime plus x times y is equal to x times y squared. And with Bernoulli, we say that n is equal to this value. So n is equal to 2. And then we say that v is equal to y exponent 1 minus n. So in our case, v would equal y raised to negative 1. But instead of saying that, we could say y is equal to v raised to negative 1. Because if we say multiply by negative 1 here, multiply by negative 1 here, we would get y is equal to v raised to negative 1. The next thing we want to do is get y prime. So we say y prime is equal to, we would get negative v raised to negative 2 dv dx. So this is important to note. And these two things are important to note if you're going to do a Bernoulli differential equation. So let's get started. So what we're pretty much going to do here is replace y prime with this. So instead of y prime, we say negative v raised to negative 2 dv dx plus x times, instead of y, we said that y is equal to v raised to negative 1. So times v raised to negative 1 is equal to x times, we said y was v raised to negative 1. So it would be v raised to negative 2 because we're squaring it here. And so the next thing we want to do is divide by negative v raised to negative 2 all over. So we would get it in standard linear form. So we have now dv over dx minus x times v, because if we divide by negative v raised to negative 2, we would get a negative, and we would have negative 1 plus 2, so it would just be v is equal to negative x. So now we want to get an integrating factor since it's in standard linear form. So we say e raised to the integral of negative x dx. Negative x dx is equal to, so the integral of negative x dx would be negative x squared divided by 2. So this would be our integrating factor. And so the next step will be to multiply our integrating factor by our standard linear form. So we would have e raised to negative x squared divided by 2 times dv over dx minus e raised to negative x squared divided by 2 times x times v is equal to negative x times e raised to negative x squared divided by 2. And so when we have it in this form, it will always be the integral, parentheses, we take v, we multiply it by this term. Outside we put the prime sign, is equal to the integral of negative x times e raised to negative x squared divided by 2. The trick here, normally when we do basic differential equations, it would just be this prime, but for Bernoulli we have v time. Just take a note of that. And so we take the integral of this and this. Since this is the integral of something prime, it will simply be v times e raised to negative x squared divided by 2. The integral of this is a little bit more trickier. We can do u substitution. So if we say that u is equal to negative x squared divided by 2, then our du would be negative x, and this would cancel this term out. And so we would get e raised to negative x squared divided by 2, say plus c. And so next we divide this term. So we can say that v is equal to, so this divided by this is 1, plus c divided by this would be ce raised to x squared divided by 2. And the last step, we don't want to keep our answer in v, so we want it in y. And we know that y is equal to 1 over v, so we can flip this. So we can say that y is equal to 1 divided by 1 plus ce raised to x squared divided by 2. And this right here is our final answer. So, important note, if you're going to do a Bernoulli equation, this is important, and multiplying by v here is also very important. The rest is pretty much the same how we normally do differential equations. And that's about it.